Why do we need to know the unique characteristics of figures? Geometry, a study of figures and shapes, started in the process of land measurement. From ancient Egypt to the present, subjects and methods of studying geometry have been diversified. The ancient Egyptians needed measurement to fairly distribute land after boundaries disappeared after flood of the Nile River. A study of figures for land measurement can be regarded as the beginning of geometry. Geometry is derived from a word geo, which means land, and metry, which means measurement. The knowledge in figures that the ancient Egyptians invented spread across the Mediterranean Sea, arriving in Greece. Unlike the Egyptians who valued experience, the ancient Greeks, who were accustomed to abstract thinking, built new concepts regarding figures and preferred to draw new conclusions based on the knowledge they already knew. In short, the ancient Egyptians created the concept of figures in the process of measuring land, and the ancient Greeks purely studied figures academically and developed them into geometry. Thanks to Thales, the father of natural philosophy, and Pythagoras, geometry attained a great development. Thales proposed a theory on two congruent triangles and proportionality. The school of Pythagoras discovered and proved the Pythagoras Theorem. Euclid wrote Stoicheia, known as Elements, that contained the comprehensive knowledge of geometry at that time. Through this compilation, he completed the system of Euclidean geometry, the elementary geometry. Humans have an instinct to draw various situations encountered in everyday life into a picture. Therefore, to find out the secrets of nature, we must first closely observe plants and animals, the components of nature. Plants and animals reveal distinct characteristics through their unique designs. Thus, it is very important to find unique designs through observation in studying mathematics. If you can find a unique design through observation, you can draw it into a picture. A picture is a different way of expressing figures and a starting point of finding the secrets of nature. It is also a step into mathematics, where all subjects are in a certain shape. We study figures to solve mostly the problems in our daily life. In addition, we can expand characteristics of figures to new mathematical theories and apply them to high technology. The purpose of studying mathematics is because the benefits that mathematics bring to us are very huge. Mathematics is a subject that helps people live happily. High technology is closely related to happiness. Mathematics considers delicate human mind and it has a potential to realize humanity's eternal dream of longevity. If we discover the secrets of nature through mathematics, we can make things that can make people happy. Since we are a part of nature, so the secrets to make us happy should lie within it. Let's assume that a person developed cancer. It can be said that the person has a big problem. Likewise, it can be said that nature also has a huge problem because humans are a part of nature. Nature has solutions to solve problems when something bad happens to it. substances to treat cancer is not a subject to newly invent. It probably exists in nature as a form of compounds. Therefore, substances that treat cancer is not a subject to invent, but a subject to discover. That is why researchers, who develop new medicines like cure for cancer, today spend much time outdoors like Amazon forest and try to study nature rather than staying in their labs. To find out the secrets of nature, you need to get closer to it. Figures in geometry may have truths we do not yet know. The ancient Egyptians used stakes and ropes that did not have equally spaced markings on them for measurement. People who were good at measurement were mostly natural philosophers. They intuitively understood the beauty of nature by observing nature by experiencing it firsthand. Today, students look for rulers and compasses to study geometry. Markings on rulers helps to draw figures with constant lengths and shapes. It is also possible to cut a certain length of line into several shorter lines in equal lengths. A ruler is a convenient tool that connects dots. A ruler and compass are essential for students to draw or divide a line at the desired length. However, for the ancient natural philosophers who skillfully drew figures with only stakes and ropes with no markings, geometry of mathematics was a hobby, or an entertainment. The ability to see the invisible is essential in today's world, where creativity is demanded more than ever. However, this ability does not just come for free. In addition to this ability, to achieve the ability to hear the inaudible, we need to learn from the ancient Greeks, who tried to measure figures with ropes without markings. As mentioned earlier, the beginning of geometry coincided with the beginning of the civilization. As civilizations arose and technologies developed, people gave up the nomadic lifestyle of constantly moving to find foods for livestock. They settled to live together and practice agriculture along the rivers. But to farm, they needed water. They also needed to know how to measure and draw plans to distinguish paddies and fields. For this to be possible, they had to understand how to draw shapes and their characteristics. From ancient Greece, drawing figures has been an important part of mathematics. Plato, an ancient Greek philosopher, said, "God is always doing geometry." In nature, there are a lot of objects that have beautiful geometric shapes. If God made this beautiful nature, there is no doubt that God is a mathematician who is proficient at geometry. The geometry that is discussed here means drawing figures. Geometrical construction in Plato's times was to draw necessary figures by only using a straight edge and compass several times. A ruler is used to draw a straight line. A compass is used to draw a circle. In the other words, Plato's geometric construction calculates a finite number of points of intersection between lines, a line and circle, and circles. Figures can be drawn by connecting the points of intersection. Today, students studying figures can easily draw them such as points, lines, circles and others with convenient tools like rulers or compasses. Moreover, They can also easily measure lengths, areas, and volumes of various objects we encounter in our everyday life. Why do we study triangles and squares? To answer, we need to look at items and buildings that the ancient Egyptian or Greeks used and built. We have to understand how they discovered and utilized the unique characteristics of shapes such as triangles, squares, and circles. If we can look into their times, studying plane figures like triangles, squares, and circles would be very interesting. How did natural philosophers establish mathematical grounds? Geometry started from the needs of everyday life in ancient Egypt. In this period of time, the techniques to measure various shapes of lands were highly developed. However, most ancient Egyptians were only interested in measurement and calculation to solve imminent problems. They did not pay much attention to study on figures themselves or fundamentally analyze structures of the figures. Egypt's geometry failed to develop a logical system with definitions, axioms, and proofs. It was also too empirical and heavily focused on everyday life. Therefore, to be precise, it wasn't sufficient to call it geometry. Thus, ancient Egypt's geometry, which was built upon practical knowledge, was not able to advance anymore. Moreover, from the fact that Ames, who wrote the right mathematical papyrus, was a scribe, the study of geometry was only for the elites. Ancient Egypt's geometry had a limitation from the very beginning. However, it is still true that ancient Egypt's geometry played an important role to the birth of ancient Greece's geometry. Most of the mathematicians in the early period of ancient Greece spent time in Egypt, an advanced civilization at the time, to study geometry. The ancient Egyptians' practical knowledge and the ancient Greeks' rational thinking contributed to the birth of logical and systematic geometry. The ancient Greeks thought that knowledge of geometry should not be obtained through repetitive experiences and trial and error, but through a clear and systematic logic. In particular, Thales, who emphasized on nature, contributed to logical development of geometry by using proofs for the first time. This is the beginning of the study on plane figures such as triangles, squares, and circles. These figures were first compiled in a mathematics book written by Hippocrates around 400 BC. The figures or geometry had been studied and developed for a long time from Pythagoras to his disciples. Thales, a natural philosopher, is known as the father of Western philosophy. When he was alive, he was already recognized as the greatest among the 7 wise men of ancient Greece. Ridiculous mistakes of famous people often become interesting topics that others talk about. Thales also made the great mistake that people are still talking about to this day. One day, he fell into a puddle under his feet during as he wandered around while looking at the sky to study the laws of the universe. It is said that a maid from Trachea, the southeastern part of the Balkan Peninsula, mocked him and said, "A man who studies the laws of the universe cannot even see the puddle under his feet." This story is often quoted to criticize people who have reached a high academic level, but know nothing of the world. Thales, a natural philosopher, asserted that water is the first principle of everything. His philosophical thinking drew conclusions through putting all the results from observing nature together. Very little is known about Thales. All we know today is that his ancestors were Phoenicians, a region today from Lebanon to parts of Syria and Israel, and he came from a prestigious family in Miletus, a small city built on a reclaimed land in Asia Minor, today's Turkey, not from the mainland in Greece. Given that even Aristotle, who was born 250 years after the birth of Thales, did not know much about him, it seems like there were not many records about Thales from the beginning. From today's perspective, this is hard to understand. However, it is not unusual when looking through the life and attitudes of intellectuals in ancient Greece. Intellectuals today often expose themselves to the world and vocalize their opinions. However, philosophers in ancient Greece regarded silence as a virtue. When the philosophers, who usually were silent, suddenly said something, what they said was highly regarded to be the guide of life and had a huge impact on many people. Thales, the father of Western philosophy, was one of the typical intellectuals in Greece. All he left to us was only 3 quotes: that water is the first principle of everything, earth floats on water, and all things are full of gods. The origin of philosophy is in nature. It means that nature was the first subject of study. Natural philosophers believed in absolute truth, which is a complete separation of truth and feelings. The change in focus from nature to humans and society in philosophy brought about the golden age of Greek philosophy. According to ancient Greek realist philosopher Aristotle, Thales also said to have attempted to argue with some proof on his principle that everything comes from water. But Aristotle himself could not find out what methods Thales used to prove it. At the time, scholars most likely considered Thales' proof to be from one of 2 methods. First, we can find evidence from his experience in Egypt. Egypt was an advanced civilization that was highly developed in astronomy, meteorology, mathematics, navigation, and other areas. During his youth, Thales stayed in Egypt. Ancient Egyptians lived affluent lives because they had the Nile River as their basis of life. The Nile River determined the size of the delta land and wetness of the land, which had a critical impact on the size of arable land. This naturally led Egyptians to worship water. This seems to have affected Thales' view of the world. Some scholars look to Thales' view on nature to have influenced his regard for water as the primary principle. Observation of nature was life itself to Thales. Thales was not one to rely on the supernatural forces to understand the world. If possible, he tried to look at the world objectively to find the fundamental principles of everything. Most living organisms need water to grow and maintain its life. Therefore, it seems reasonable for Thales to come to a conclusion that water is the primary principle of all things. Of course, we don't need to understand why Thales believed that water is the primary principle. Thales deserves credit for applying philosophical way of thinking to understand the world by observing nature. Even today, his work on definitions of shapes can still be seen in middle school textbooks. Examples include Thales Theorem, which states if A, B, and C are distinct points on a circle where the line AC is a diameter, then the angle ABC is a right angle. His theorem also states that if two sides and the included angle of two triangles are the same, then the two triangles are congruent. Many more were defined by Thales. Plato was an idealist philosopher during the 4th century BC. His school began to thrive as his philosophy started to dominate Greek's world of knowledge. Around this time, constructive geometry, drawing figures using straight edge and compass, was a trend. In the West, Plato from ancient Greece started the tradition of constructing using only a straight edge and a compass. The reason Plato insisted on constructing with only straight edge and a compass is because he believed that straight lines and circles are the only perfect figures, and so God would regard them highly. Constructing figures was also widely used in ancient Egypt. Around 3000 BC, King Menes unified Egypt and named kings a pharaoh, which meant one who lives in a great house. He claimed that Pharaoh's holy power came from the god Horus. Also, in order to flaunt the power granted by the god, Menes started to build pyramids. He wished for people to revere him even after his death by being buried there. Plane figures like triangles, squares, and circles is a field in geometry that studies the characteristics of the shape, size, and locational relations of figures on planes. You can learn most of in your elementary geometry classes. In other words, plane geometry is where we study the geometric characteristics of plane figures, like straight lines, circles, and polygons, on the Euclidean plane. The figures studied in plane geometry are in two-dimensional space, which is why they called plane geometry. Plane geometry is differentiated from dimensional planes, which is in three-dimensional space. For example, studying straight lines on planes is plane geometry, and studying straight lines on three-dimensional space is solid geometry. As mentioned earlier, plane geometry is also called Euclidean geometry. Euclidean geometry started around 300 BC from the elements written by Greek mathematician Euclid. 17th century French mathematician Descartes designed Cartesian coordinate system. The result was the birth of Cartesian geometry, where one solves problems related to or prove figures' characteristics using analytical theories. Coordinate system is used in analytical geometry. If there is one axis, it is a straight line, 2 is a plane, and 3 is a space. Thus, if we use two coordinate axes that intersect, we can make a coordinate system to study the characteristics of plane figures like a straight line, circle, and polygons. As such, the method of proving a mathematical sentence as true using logical deduction started from the Greek era and became the basis of pure mathematics today. Since when and where were principles of triangle applied? Plane figures such as the triangle, rectangle, circles are used everywhere. For example, a saw, used to cut trees, has the shape of an isosceles triangle or a right triangle. A triangle has a sound shape that doesn't easily change. Since the teeth of the saw are triangles, they can cut through trees and the blades can last long. When you look closely at the indentations on small bolts and nuts, you'll notice that the indents are an isosceles triangle. The triangular shapes of bolts and nuts allows to fit perfectly, which is why they don't come up very easily once secured. The invention of bolts and nuts brought about the advancement of the machine industry. For example, the excavator has a shovel with triangular teeth on the front which allows it to easily dig up hard grounds. A triangular structure is essential to build sound structures. Triangles have the characteristic of having a fixed shape once the length of three sides are set. The Forth Bridge in Scotland is a steel bridge made up of many iron beams forming triangles. The Eiffel Tower is the tallest triangular-shaped iron structure. The tower consists of big and small triangles. The John Hancock Center in Chicago is known as the skyscraper with triangular structures on the outside. We can see a glimpse of how people in the past understood triangles through their math. For example, Ames was a scribe from the ancient Egyptian era who recorded about ancient Egyptian mathematics on the papyrus. In this document, there is 87 math problems and solutions. In fact, problem 51 is about how to find the area of a triangular land. To find the area of an isosceles triangle, first divide the triangle into right triangles. Then, stick the two triangles together to make a rectangle and find its area. Even 3,800 years ago, ancient Egyptians knew the relationship of the area of a rectangle and a triangle. No matter what triangle was given, they could express it as the sum or difference of two right triangles. In other words, if you understand the right triangle, then you can almost everything about triangles. Then why did the ancient people try to understand triangles, and where did they use this knowledge? Thales, the father of philosophy, was also Greece's first mathematician. He proved that the two base angles of an isosceles triangles are equal. He also proved that two triangles are congruent if two corresponding angles and a side is equal. Such mathematical knowledge did not just stay in Thales' head. Thales knew he could apply such characteristics of triangles to find the height or length of objects in our daily lives. He was especially interested in studying right triangles. Pythagoras, who lived in Samos Island in the Asia Minor region, was also interested in looking at right triangles and objects with similar shape. Thales figured out how to measure an object's height using shadows. He first considered the height of the center of an object he wished to measure as the reference point. Then he compared the length of the reference point's shadow and the shadow of the stick to calculate the actual height. Studying math and science in Egypt, Thales was interested in the height of the Great Pyramid. How can one measure the height of the pyramid? Although the Egyptians built a Great Pyramid, They did not measure its height and didn't think of using triangles to measure the height. However, using the length of shadows, Thales was able to measure the height of the pyramid only using a stick. He was able to do this measuring the shadow's length using the triangle, the stick perpendicular to the ground, and the length of the stick's shadow. Likewise, the research and passion for triangles was great, by applying the principles of right triangles in real life. Problem 56 in the oldest math book, Ames Papyrus, is about a pyramid. This problem is about right triangles, using the pyramid's square base and height as an example. The problem is to find the sect of a pyramid that has a height of 250 and the side of its base square equals 360. Here sect means the ratio of the two sides in a right angle. This problem shows that in a right triangle, the slope of the hypotenuse changes according to the ratio of the two line segments that forms a right angle. The base of a pyramid is a square, so the interior angles of the base are all right angles. Thus, we can infer that right triangles played an important role during the construction of the pyramids. The pyramids, a cultural heritage from ancient Egypt that contain triangles, is one of the greatest construction built by man. The depth of the mathematical knowledge the ancient people had, especially on triangles, was fully utilized during the construction of the pyramid. In this sense, the understanding of triangles is really the math within civilization. In order to measure distance, our eyes use the principles of an isosceles triangle, meaning there needs to be 3 points to accurately measure distance, namely, 2 points in your eyes and the object we're trying to measure the distance to. That's why when we cover one of our eyes, it is hard to estimate the distance. In other words, there needs to be 3 points to accurately measure distance. Using this principle to measure distance on land is called triangulation, and GPS is an example of using this technology. GPS is an acronym for Global Positioning System. It is not only used on planes, ships, and cars but also to accurately measure any locations using satellites. GPS is not only used to provide location, but also used extensively for research on oil tanks, anti-collision systems, accurate measurements on large civil engineering projects, mapmaking, and many other fields. The bottom of the pot used in cooking is around to efficiently transfer heat. The distance from the center of the circle to the outer edge is all the same. Thus, when heating up, since the base of the pot is round, the heat gets transferred throughout the pot, cooking the food evenly. A manhole is a hole to allow people to manage the sewers under the ground. Upon closer inspection, you'll notice that most manholes covers are round. Why are manhole covers always a circle? Why not a triangle or square? Let's make one ourselves and find out. Using a ruler and compass, draw a circle, triangle, and square and carefully cut them out using a knife. Now try to put the shapes back into the holes you made. No matter what direction you put it in, a round manhole cover does not fall through. However, With a triangular or square manhole cover, it slips when not aligned properly. This is because of the circle's width. For example, let's say a side of a square is 10 centimeters. Although all sides are 10 centimeters, the length of the diagonal is 14 centimeters. Likewise, an equilateral triangle that has a side of 10 centimeters has a height of 8 centimeters, which is shorter than the side. In other words, both the square and equilateral triangle have different lengths depending on how it is measured. Because of such difference, when the shorter side is put through the longer side, the cover will fall through. Then what about a circle with a radius of 10 centimeters? Since the length is always the same no matter where you measure it, it will not fall through unless you fold or cut it. This is why manhole covers are round. Plane windows are also round. This is because round shapes can evenly distribute impact and pressure. Pythagoras, the father of Greek mathematics, made the Pythagoras Theorem after finding characteristics of right triangles. Ancient people found order and rules in triangles. To them, a triangle wasn't just a shape with three sides but in mathematics in a shape of a mountain. Furthermore, Pythagoras and his followers, who tried to view everything in the world into a polygon, studied math using humanities as the foundation.